Welcome everyone, and thank you all for joining me today to this advanced training number 3. My name is David from ComfortClick. As mentioned, today's course is going to be all about tasks. And this is the course number 3. So if you want to know a little bit more, how the whole ecosystem works, how the configurator looks regarding the visualization aspect and about the general, and if you want to know a little bit more how the integration with devices work, I would suggest you to also watch our training courses number 1 and 2. There is where we cover, the devices and the visualization. Because today's agenda, we're going to be mostly or exclusively talking about the tasks that we have in BOS. There are going to be a couple of our support team in the chat. So if you do have any questions or if there's any issues, please just use the chat here in the Teams, and our support team will try and help you out as much as we can. And also at the end, you'll see we also have a nice little Q&A as well, where we can have a little bit more of a chat, or maybe I can answer a couple more questions. So let's just open the agenda for today. As I mentioned, I'll go through basically the whole idea for today. As I will open up the configurator, show my screen, and basically go from start to finish. Open all the tasks, explain in great detail how everything works, where everything is located, how to set up the task. And then also I have a nice simple little visualization also prepared, where I'll also be showing you, how everything works in the client. After all the tasks are explained, we're gonna have a short little break. And then after the break, we're gonna be doing very simple exercises. So if you're gonna be following along today, it should be pretty simple. And then after that, we're gonna have a general Q&A where we can have maybe a little bit of a chat, and we can, discuss how tasks are being done in BOS. Okay, so I'll just drag this window aside and we can take a look at it later. Okay, so as I mentioned, this is the configuration that I have prepared for today. As you can see, I have all the tasks that are currently supported by BOS. Maybe I can just have a chat window open somewhere. Okay. All the tasks that are supported by BOS are listed here. I do have a couple of variables also added in, so I can maybe refer to them, maybe a little bit easier to understand. And I'll basically go from start to finish, explaining each individual task, how everything is done. Okay, so to start off, the first task that we're going to take a look at today is going to be our analog log. So the best use case for the analog log is, of course, for data logging. So using the analog log, we're mostly logging, values that are coming to BOS. In most cases, these are temperature, weather information, and so on. And basically, all you need to do in analog log, you need to select which data you're logging. So under input value, I'm just going to select my variable here that I have, value 1. And now BOS is going to log what is going on with that data. There are, of course, a bunch of different functions or additional functionalities that can be added to this analog log. First is the limit database writes. This function basically, if I have this disabled, then everything that is being sent to the log is automatically stored. So to give you an example, if I write the value down, let's say, 1, 2, 3, 4, and 5, for instance, just to give an example. If I open up the analog log, you can see all the data is automatically saved. So this is very, very useful if you want to log every specific data that comes to the log. So every value that is changed, you need it to log, then this is the perfect function to use. In most cases, how people are using the analog log is they use write intervals. So this write interval is basically a time interval in which all the data that is being saved is then saved after the interval is over. So here you can say a specific time. So let's say, 300 seconds. For today, I'm just going to use 4 seconds because, we don't want to wait 300 seconds in order to write something in the log. And then on the write type, this is where we select what we are writing into the log after the time runs out. So in most cases, you can either write average values, minimum, or maximum values. So all these settings can be changed in order to write the information that you want. If you want to delete the, let's say, old logs, let's say if you have analog log running for a year or two, and of course the data is combined and saved there, the file is getting bigger and bigger, you can also enable the delete old data function, which means that after certain a number of days, old data is going to start being removed from the log. So after, let's say this is 720 days by default, after 720 days, all the older data is then going to be removed or being rewritten with new data. But if you don't want the log to be deleted, and if you want to have log value stored for 5-10 years, you can of course disable this, and all the data is going to be constantly saved. At any point, you can of course export your values, right? So all the values that are in the log are saved here, and if you want, you can export these, say as an txt file, which you can then of course view, or you can also back up this file. This backup file is going to save as a .db file for database, which you can then also alter or view in any other program or software for data viewing or whatever. Okay, so currently we have, as you can see here, I have write interval set to 4 seconds, and what this means that when I now start changing the value, let's say, I don't know, 6, 7, and 8, within the write interval, BOS is now going to save the average between all of those values. And if I refresh the log, you can see 6, 7, and 8, the average is 7. And that is the value that is then being saved to BOS. And you can tweak this value or tweak this setting as much as you want and get the data that you need. If for any reason, maybe the device, there is a delay, okay. If for any reason the device is sending either the wrong data, or you want to change the, let's say, if you want to scale the data up or down, you can use scaling data here function. So the way the scaling works, as you can see, we have K and N settings or values here. K is basically multiplying the value, and the N is then adding to that specific value. To give an example, if we write down, let's say, I don't know, let's say if we add scale data enable, and if we set this to 2 and maybe set this to 5, so times 2 plus 5. Now the next time the log is going to send value, let's say 10, BOS is then going to multiply this 20 and add 5. And you can see that the log is going to save the value 25. So this is just, for instances, if you for any reason want to scale the input data and then display it, whatever you want. If I open up my client, we can also already see that BOS is already creating the log for us. So here you can see the time, and then you can see the log being created. Of course, unfortunately, we only have a short period of time, only a minute or so. So I can kind of see how it looks. But if I open up the demo project on our website, you can kind of see how usually how the analog log looks. So here you can see you have the values being saved in a nice little I should say log, and you can of course scale or see what was happening during the days, the months, and the years, as long as the log has been active. This is for temperature, so you can see how the temperature fluctuates in the morning, in the evening, but by time and so on. So this is usually how the log looks after has been used for a period of time. If you want to tweak the values, or if you want to change the log the way it looks in the visualization, you can go to the themes, and I'm going to select my analog log, and this is where I have the log. And here, if you go to objects, here you can select the log, and this is all the settings that you can tweak, right? You can change the colors, you can change the title, you can change displaying value, so you can say the log will also display maximum, minimum values as well. And here you can also add another log in. for instance, if you want to have, let's say, 2 logs displaying in the same visualization. So I just created another copy of my analog log, and I'm just gonna save just a random value in. So just so I can show you, let's say, I don't know, 15. Save this value 35. Of course, we're scaling it. If I also want to include this log in my current log, because a lot of people are maybe showing 2 separate values, or maybe they're combining or comparing different log values. Here on the collection where we had the current one, we can also add a new log in. So this is the new one that I created. Maybe I can change the color so it's a little bit more visible. And now we have 2 logs displaying. Unfortunately, it's not going to be as visible, unfortunately, because we have a short, a very short time span that the log has been active. But here at the top at the legend, you can see that now we're currently displaying two different values here. So if for any reason you want to display more than one value in the log, this is the way to do it. Okay, so on to the next task. The next task that we have is going to be our analog threshold. So the way analog threshold works is you, of course, select the input value as we usually do. You select which value we're looking at, and then we're going to tell what kind of threshold we have, and then we're going to control other devices depending on if the value is above or below the current threshold. This is mostly used for brightness control or maybe irrigation system, wind speed alerts. If you have, let's say, if the wind speed is above my current threshold, then I can send a notification, for instance. And here we have 2 different thresholds that we can select. The first is going to be the single. So this is just one threshold value we can select. And here we can have some time delays. So it's not, constantly changing value as soon as it goes above the threshold. You don't want, the device to constantly send you values each time it changes. And here we can set the threshold, let's say 15, just to give an example. And then we can also add hysteresis value in as well. So hysteresis is just going to be a little more of a wiggle room. So the value needs to go a little bit above or below my current threshold. So let's say if we set the threshold to 15 and then hysteresis to 2, the value needs to go above 17 in order to threshold value to change. So to show you in the client how this works, so currently we have the threshold. Let's say we change it to, I don't know, 15, for instance. We're going to say, and then our current value, let's say it's going to be 1, just to see what's going to happen. And let's go, we need to go above, like I said, we need to go above 17 or 18 in order to value to change. And as soon as I drop below that 15, on the 3 seconds, the 3 second here. As soon as we drop below my threshold value, you can see the analog threshold went to off. There is a short delay here, 3 seconds for true and false that I set. Just so like I said, it's not the analog threshold isn't constantly changing, right? Every time we go off and on and off, it's going to be too much of a change to the device to constantly send the value. So for the analog threshold is 16. As soon as we go, above or at 18, we should see the analog threshold turn on. And this means that now we can, turn a specific device on or off, maybe send a notification, or, do anything basically that you want in the building. So this is for the single threshold, but here we can also have high and low value. So this is just, another way of adding some additional, functions or additional options. Instead of playing or adding the hysteresis value, we're going to tell what's the high and what's the low limit. So that means that if the value goes above 10, then set the threshold to true. And when the value goes below 5, in this case, set the threshold. And everything that's in between is not going to change. So as soon as we go threshold below, let's say 5, we can see that in 2 seconds, the value is going to turn off. And now the analog threshold is not going to turn on until we reach the upper limit. So this is, it's not going to change if we go to 9, even though, in the past, if we set hysteresis to 2, that should change. We need to go above the higher limit in order for the threshold to turn on. And then just again, you can apply this to wind speed, temperatures, whatever in the building you can apply this to. Then at BOS is then going to control devices depending either on your threshold or let's say your upper or lower limit. The next task we're going to take a look at is going to be our bit converter. So what bit converter does, bit converter basically converts decimal values into binary, right? This is very useful for sending, decoding for decoding errors, decoding information from the device. And the way it works, again, we select our input value, and the bit converter is now gonna decode or convert the decimal value into binary. I have a very nice example here that I can show you from my cheat sheet here. This is just an example that I can show you. Let's say the device sends an, let's say, status in, let's say, 12. The devices will send or error message or notification or whatever. The devices will send 10, and then each individual bit in this, let's open up this, each individual bit within this message means something else, right? So bit number 1 means do protection active. Bit number 9, visual gravel, radiation sensor invalid. So each individual bit means something else. If I go to my client and open up the bit conversion, we can see now let's say the device is sending us value 10. And then if I read the manual instruction, we can see the bit number 1 means, I don't know, high temperature. And then bit number 3 means, smoke protection active or something like that. So you can decode these values according to the device's manual, for instance. So this can be, either error messages or status values from the device, which you can then, decode. And of course, you can change, of course, the name here. Instead of bit 1, you can change, alarm active or high temperature, wind speeds are high, and so on. So again, you can apply the same thing to, multiple, cases, of course, all depending on the device that you maybe have. So as you can see, nothing too complicated regarding the bit converter here. As I said, just simply decoding or converting decoding the decimal to binary values. That's all it basically does. So the next task that we're going to take a look at is going to be our calculation. So calculation is very useful task because it's kind of a built-in calculator in Word in BOS. Using this calculation task, you can of course calculate values. You can calculate specific numbers, or you can actually calculate between other values within the configuration. It's used to maybe convert certain values. You can use most times also using for converting or calculating some consumption measurements and so on. So it can be used in a variety of different things. The way it works here, we can either, of course, enable or disable this calculation. We can change the calculus, so we can change from constant to integral or derivate. So all of these options are available. And we can also use the constant factor as well. So this is the way you can use constant factor to convert certain values, use it for consumption calculations and so on. And the way the calculation works, every calculation that is being done is done here under operations. So all I need to do is I need to add an operation. And this is going to be basically our calculator in Word. So this is the window that we're going to be using to calculate between values. We can either select the number which we're calculating with. We can add functions to it. Sinus, cosinus, and other functions can be added. Instead of using a number, like I mentioned, we can also use our input value. Maybe this value number 1. This could be, let's say, that we're calculating with. And if we want to use brackets within the calculation, the brackets are done using the sub operations. So as soon as I click add, now this is a bracket that we're now currently using. So if I just select my input value and click OK, you can see that now BOS this is the first value that we are using to calculate. And then the next step we can do is we can click add again. And you can see now BOS is now asking you, okay, what am I doing with this number? Am I adding different values? Am I subtracting, multiplying, or am I dividing between other values? And this is, you can choose whichever calculation that you want to do. Let's say we want to multiply this. We can multiply it by 5, for instance, just to give you a simple example. And when I do this, we can see that BOS is now going to do value number 1 times 5. And if I change the, let's say, value number 1 to 5, BOS is now going to calculate 5 times 5 equals 25. And this is, the way the calculation is done. And then you can use this calculation value maybe in logs, maybe in, displaying it anywhere else, or using it maybe in other tasks within BOS. You can also, of course, instead of just multiplying it by a specific number, you can multiply or add it to another input value. This is where you can also kind of calculate between input values as well. But if you want to use, let's say, a brackets, the way you can create brackets is you can go just here, let's say multiply, and now we're going to add a bracket. And in this bracket, I'm just going to calculate value 2, and let's say just plus value number 3. So what this calculation is now going to do is going to see, you can see we have an input value, which is the value 1 times value 2 plus value 3. This is just, to give an example how, what you can do it, 5 maybe, and maybe 5. So this is going to be, again, the calculation is going to be 50 because we have 5 plus 5 times 5, basically. So we have 10 plus 5 is 50. And this is just to give you a simple practical example, the way the calculation can be done. If you want to, let's say, convert specific value, let's say you want to convert the, let's say if you want to convert meters per, if you want to, if you want to convert meters per second to, let's say, kilometers per hour, all you need to do is you need to change the constant factor here to 3.6. And now BOS is going to automatically convert the output, basically. So if we have value 1 is 5, 5 meters per second is 18 kilometers per hour. So this is another way you can maybe use the calculator to convert values and do some additional calculations. Okay, so the next task is going to be our counter log. So counter log is in a way fairly similar to our analog log, but counter log is mostly used for logging measurement or measurement consumption, basically. The same as we did with the analog log, we need to add the input value. So this is the value that we're going to be logging. And as you can see, there are no intervals or whatever. Here we have the only thing that we need to do is, if I just change this value so I can show you, let's say 500. Analog log is going to be saving this value by hour, basically. So we are looking at the let's say consumption per hour regarding this could be any specific input device, and then each individual hour, the next value is going to be saved. So let's say currently this device is consuming 500, whichever unit you have, and then in the next hour it's going to consume 550, so it's going to consume 50 more, and the log is not going to then save 550. It's only going to save 50 because we have, it's going to retract from the previous value. I hope that makes sense. If for any reason that the device is sending negative values or it's going in the other direction, we can also enable this ignore countdown value function, which means that it's not gonna be going into minus or messing up your log, basically, because it may happen if you're logging for longer periods of time. For some reason, some devices may send a value to 0 or send a wrong value, a negative value, and then it basically disrupts the whole log. And if I open up the client, the counter log it's not making a continuous line, is making bars hourly, but is making a hour bars, basically. And if I open up again, we can go to our client, and if we go to consumption and maybe gas, we can see the, let's say, use case for the way the consumption bar looks. So you can see we have either by day or by hours, basically showing you the consumption value going up or down, and you're maybe not showing and so on. So you can expect, your counter log to look quite differently if you look at the analog log, because you don't need the constant value change there. You can only do it by hour. And of course, scaling data applies as it does with the analog log. If for any reason the device, or you want to scale the data that comes in, if you want to scale it, you can of course enable scaling and then play with the K and N value to scale, either multiply or add the value in. The next task we're going to take a look at is going to be our gate. So gate is, for most cases, used for security reasons. You can add an input value, are usually the door window sensors, something like that. And the way the gate works, we add our input values in. You can simply drag and drop them in. So every input value that you need to check, you can drag and drop it in. And then we are using the type of our gate to either turn the gate on or off, right? So if we can choose between OR, AND, or XOR. That means that if we choose OR, and if I go to my client, I can show you very easily how it works. So currently we have it set to OR, which means that at least one of these needs to be turned on in order for our gate to turn on. And it doesn't matter if I have more than one, as long as I have one on, the gate is going to turn on. And like I said, you can apply this to windows being open, doors being open, and so on. If I have, let's say, AND, that means that at least more than one need to be turned on in order, or I mean all of them need to be turned on in order for the gate to turn on. So this is what AND does. So like I said, you can set this to notification when all of the windows, or if you have two windows, if both are open or doors, send a notification, sound the alarm, do basically anything that you want. It all depends on the type of gate that you use in here. And of course, if you go to XOR, that means that if I turn one on, it's going to turn on, but if I turn the next one on, it's going to turn off. So it's going to do the kind of the opposite of an OR. Very simple task, very easy to configure. And if you want to change the output value, you can of course link it to any output value, or you can also invert the output value if needed, of course, as well. So these are all options within the gate task. The next task we're going to take a look at is going to be our messaging task. And messaging task is very, very common and very important task within BOS. Just because using the messaging task, we are notifying our clients what is happening in the building, right? We can choose between different types of messages. We can either choose the event. That means that the client, if it has a client open, they can see the event, what's going on in the building. We can send an alert. We can also send an email, for instance. So emails can be sent to our clients. And in order for the client to receive the email, you need to go to the users, select the user, and then type in the email address here. If you don't type the email address in, BOS doesn't know where to send the email notification. So as soon as you type in your email here, BOS is then going to send the email to this specific address that you set. And same goes for text messages. If you want the BOS to send you a text message by notifying you what's going on in the building, you need to add your phone number here actually in order to receive this message. We can also write to log. So every time a notification is sent, we can write to log. Here we can add a subject. So what's the title? Basically a message, just to give an example, message. So on, we can add this. We can also block sending, which means that when the notification is sent, in the next, whatever minute you say it, the messages are not going to be sent. This is mostly, if for any reason you have a trigger that the device is sending a message to the client, and if for any reason the device is constantly, changing, especially if you're testing something, you don't want to send hundreds and hundreds of emails and text messages to your client. You can block after a specific number of minutes, and then the client is not going to be overwhelmed with notifications. You can of course send, and it can be an image, can be sent. You can also select between with all of our sounds. It can also be as notification, and you can also add the text to speech to be sent to the client as well. The way we send notifications is, of course, by using triggers. So you can add basically anything here as a trigger. This could be, movement detection, flood detection, fire, whatever, or high wind speeds, or open door when everything is locked. So we can use this as a trigger to then send notifications, right? You can send an email, text message, call to your client, and they can be notified what's going on in the building. The message that is going to be in the message task, or the text is then typed in here, right? So you can say, I don't know, alarm in room 2, example, and when the notification is going to be sent, the client is then going to receive the value. If you want to send a variable value, you can also do this by adding variables here at the bottom as well. So I do have just an integer value prepared. And what I'm going to do is I'm just going to add it in. And now if I want to call out this number, I need to use the percent and let's say current value. I need to then add as you can see here, it's actually written down what you need to do. You need to put the percent value, and then you need to put the number that is associated with this variable. Currently, as you can see, I have 1 or 0. And if I type in 0, then BOS is going to call out this value and display the current value. If you have more than 1, if you want to add more, you can then just use percent 1, 2, 3, 4, 5 to maybe call out different values within the configuration. And if everything works correctly, we can change the value to here, let's say to 10. And if I manually send the message, you can see message current value is 10 because we are sending this input value. And if I change it to 15, now it's going to be 15. And again, you can apply this to current temperature, current wind speeds, movement in, and then you can write down a specific room. Again, this can be applied to a variety of different things within the configuration, and you can then send the messages out. The next task that we're going to take a look at is going to be our min-max and average task. So this is pretty straightforward and pretty simple task. All this task does is it takes the we drag and drop the input values, so value 1, value 2, value 3, and then this task is gonna calculate these values and show which is the minimum value, which is the maximum, and what's the average value. And I have a nifty little visualization also prepared where we have all the 3 values, and then at the bottom we have the calculation basically. And if I increase, let's say, value 1 to 5, we can see that maximum value is now 5, minimum value is of course 0 because they're both 0, and then the average is 2. And if I increase this to, let's say, 10 or whatever, that doesn't basically matter, we can see now that this is now the maximum, this is the average is 5, and then minimum is still 0. And you can then use, let's say, consumption values, other values within, the configuration, and you can kind of then compare, right? You can have consumption for building number 1, consumption for building number 2 or 3, 4, or your devices, and then you can see which is, who is consuming the most, who is consuming the least, what's the average consumption, whatnot. So you can, use a variety of different options here to, show the minimum, the average, and of course the maximum value within the input values. Fairly simple task, but can be used in a number of different ways, and can be very, very useful, especially if you want to simply calculate basically, or display values in the configuration. The next test we're going to take a look at is going to be our movement detector. And what the movement detector does, basically, roughly if it detects movement, then it turns on a specific device. This is a perfect example to show the communication between different devices, because here we can have, let's say, Z-wave input detection, so motion detector, and you can have maybe KNX, KNX light, or maybe you can have a alarm, DSC alarm, whatever, to turn it on or do anything else. So this is a perfect example of combining or communicating between two completely different devices. The way the movement detector works, simply under input values, add your movement detector. So this is going to be our movement, and the output value is going to be our light. So light, and click OK. And if I go to the client movement detector, as soon as the movement detector detects movement, the light turns on. And it's as simple as that. There is a short delay of 1 second or so for the light to turn off, but the light turns on when this movement detected. This movement detector will also allow you to add additional conditions. So let's say you can also block the movement detection by output. This means that if I enable this, if the light is turned on, you can see now the movement detector is being blocked. So the movement detector currently isn't detecting movement if the movement detector has this option, because the light is already on and there's no need for the movement detector to do basically anything or detect movement. But as soon as the light is off and there's movement, the light turns on. And we can also add additional operation conditions. So currently, each time the movement detector detects movement, it turns the light on. But we can also add different conditions as well. So let's say we add our night value. So night value is used when maybe with it's bright enough so we don't need to turn on a specific light, right? So if I add the night value here, click this OK. Currently, it's not night, so it's bright enough. And if the movement detector detects movement, the light does not turn on because it's already bright enough, and we don't need the extra light. But as soon as the night goes on, and this, of course, night can be linked to sun position, time, whatever can be linked to this night. And as soon as the night is true, which means it's dark enough outside, when the movement detector detects movement, the light turns on. Just very simple, but we can add additional conditions to turn a specific light on and off, for instance. Instead of using the night value, we can also use brightness value. We can be a little bit more specific when it's not this amount of lux brightness outside, then turn the light on, right? So let's say current brightness limit is, let's say, 200 lux, and the current brightness is 300 lux, which means it's brighter than our limit. That means that as soon as a movement detector detects movement, the light is not going to turn on, right? But as soon as the brightness goes below that 200 limit, then when the movement detects movement, the light turns on. And you can add these kind of varieties, conditions to tweak the movement sensor so it works exactly maybe as the client requires, right? By adding the night value or maybe the brightness value. Here you can also block the movement detector by any other device, basically. You can use maybe a variable, or you can maybe use another movement detector, right? So if we enable blocked, that means that the current movement detector is blocked. It's not gonna turn on a light. Maybe you have in the same room, you have two movement detectors, and when one movement detector detects movement, then it can block the other movement, so you're not constantly turning on the same or multiple light in the same room. Just give you an example what block does as well. You can or you can also turn it on, for instance, if needed. So it all depends on the situation that the client wanted. So the next text that we're going to take a look at is going to be our operating time. Again, operating time is very, very useful, but very, very simple task. All it does, it basically logs how long a specific device has been turned on. Again, we add the input value, which device we're looking at. We'll take this value, and if I go to the client operating time, you can see currently everything is at 0, but as soon as the device turns on, we can see the timer going up, right? And now it's basically logging how long the device has been turned on. And as soon as I turn the device off, the operating time stops. Then you can see you can enable this to a specific device, so you can see how long a specific device has been turned on. You can then also use this minute counter or hour counter here to maybe send notification, turn the device off after a specific time or hour, or do basically anything that you want within the specific device. This operating time will also allow you to roughly kind of display the consumption factor. So that means that if you want to display how much it consumes, you can also use this in the consumption factor. That you need to take into consideration that the consumption is constant and always the same and not changing, and you can then change. So if you want to display, let's say the device is consuming 2, let's say, kilowatt per hour consumption, when we turn it on, BOS is also going to calculate the consumption. Of course, we need to reach a specific number in order to be displayed. But if I go to the values here, you can see the current consumption being changed every second, basically. So it all depends on if the device has a constant kind of consumption value, and if of course you want to display it here under the consumption. Again, pretty straightforward, simple task. Here we can see we went past 1 minute. Now we have 66 seconds, and the minute counter went to 1. So we can now, of course, use this minutes somewhere in log maybe as well to log the specific data. Okay, so the next test we're going to take a look at is going to be our presence simulator. So what presence simulator does is the presence simulator basically simulates there's someone in the building even though there's no one there by simply controlling the devices and turning them on and off. It's simple as that. We add our devices in. So let's say these are going to be our lights, and of course you're not limited to lights. You can turn speakers on, shades down. Doesn't matter. Basically, you can turn. You can simulate that there's someone in the building by switching and controlling these devices on and off. Since we are going to be turning on these devices, I'm just going to select them all and change the value to true. That just means that when they're going to be triggered, they're going to turn on. And if I go to my presence simulator here, we can see these are the lights, and this is my presence simulator. And if I click start, then my lights are going to turn on. We can choose how many devices are going to turn on. Let's say 3 or 2. We can change the interval, so how often the lights are going to turn on and off, on and off. And we can also tweak the device list, so which light is going to turn on and off, on and off. And when we click start, you'll see now 2 lights are going to turn off. Maybe in some cases even 1 or maybe 3 lights are going to turn off. It tries to be kind of random, so it's not too obvious that there's always the same 2 lights turning on and off. So we'll kind of go and maybe one time turn one. In this case, you can see it only don't turn 2 instead of 3. It kind of takes a random value there, and then kind of just turns a random 2 or 3 lights on. And this is basically now simulating that there's someone in the building, even though there's no one there, basically. We can also, like we did with the movement detector, we can also add a night value here. This just means that if I enable light or night in this case, that just means that it's not currently night is off, and if I start it, no light are going to turn on. This just means that currently it's bright enough, and we don't need the lights to be turning on and off when it's not going to be visible. But as soon as we can turn the night on and start the presence simulator, we can see now the lights have been turned on. And this is just another condition that you can use to kind of add a little bit more variety to your presence simulator. Here we can also enable sleep time. So sleep time just means if I enable this and I send a specific time, let's say at 9 o'clock or 9:30, for instance. So here we have hours and here we have minutes. This just means as soon as the tower or the time reaches this specific time, the presence simulator is going to stop, right? You don't want it to accidentally at 1 o'clock in the morning to all the lights turn on by if someone accidentally pressed the button or something. As soon as the sleep time is enabled, then the presence simulator stops and it's not going to turn these devices on. Okay. The next task we're going to take a look at is going to be our program task. So program task is probably most commonly used in BOS or most versatile task that we have. BOS will basically allow you to do almost anything within this configuration. You can almost, to a certain degree, you can recreate other tasks using this program task. The way it works, of course, you can add a trigger like we did with any other task. So the trigger is going to then tell when this program task is going to be triggered. We do get a lot of questions. Let's just give an example value. We do get a lot of questions asking us what this allow retrigger does, right? So if I enable this, then you can see allow retriggered is enabled, or I can disable it. So what this does is, because in most cases, a specific device is not going to always send true, false, true, false, true, false. In some cases, it may be sent true, true, true a couple of times. And allow retrigger means that every time the value is going to be true, the program task is going to start. This is just something you can enable, and the program task is then going to be always triggered when the value is true. It's not going to wait, for it first to go false and then true. It's going to always enable when it goes true. And all the logic for the program task is then done here under commands. So if I go to commands, this is where we can now start creating the logic. This is where we can start creating the complexity, and we can go, we can create something very, very simple, or we can go, layers and layers deep. And the way you do it, simply click add, and this is all the functions that are available for the program task. Pretty simple. Set value. All this set value is going to do is going to set a specific value, right? Here we can see, let's say operating time is true. When this is true, then turn this light on. This is a simple example the way it does. Instead of setting value, we can run functions. So we can run scenes, run schedules, do some calculations. Maybe you can calculate, you can send a notification, you can run a presence simulator. So anything basically that is a function can be run using the program task. If you want to start adding complexity to the program task, this is where we can start adding our if sentences, right? So we can start adding ifs, right? So when the trigger is true, and if the temperature is this, and if the wind speed is that, and if the heating is on, then do this, right? You can go as simple as you want. So just trigger if and do something else, or you can add multiple ifs on ifs on ifs and create more complexity if needed. We have, use cases where people are using the program task as a presence simulator or as a movement detector, or we can have, people running a whole wing somewhere in the building using all the program or just using the program task. So you can use it, being very, very simple and easy to extremely complicated with multiple ifs. And of course, if there's an if, you can also use else. So to do this, then do that, and so on. So again, a lot of complexity, a lot of a lot of things can be done using the program task. We can also add a specific delay if for any reason the changing the values require a specific delay. We can add them in seconds, minutes, and whatnot. We can also at any point exit the program task. So let's say when you reach a specific goal within the logic, you can then exit it, the program task. You can also restart the program task. So every time you reach the restart function, the BOS is going to start the program task again. You can of course log this message, being saved in the log, and you can BOS also allow you to run HTTP requests, right? So if you have, if you know the exact, username, credentials, URL, post data, if you know all of this information, you can also run a, HTTP request within the program task. This is kind of a kind of a simplified version of our HTTP driver. Very, very simplified. It's kind of limited, but you can run specific requests using the program task. You can also run specific programs on the server as well. So if you have a directory of the application that you need to run, you can write the directory here, name, and maybe some arguments, and BOS will also run applications using the program task. And you can also wake up devices on LAN. So if a device has this option to wake the device up, all you need to do is to add the MAC address in the description, and BOS is then gonna wake up a specific device. To give you a very, very simple example, how the program can be built, we can use, let's say, I'm going to create a trigger, and maybe we go to the weather, and just let's say temperature, right? One thing we can also use here as a condition, you can select between, equals, it differs, is greater, smaller, or lower than this. So these are also conditions that you can choose with the program task. And in most cases, people are, you can either trigger when the temperature reaches a specific value, or you can trigger this program task every time the value changes. So this is a very, very useful, condition to use, right? So this program task is now going to be triggered every time the temperature changes. Now we can ask, okay, if the temperature is, let's say, more than, I don't know, 23 degrees, right? That's going to be the if. If it's more, then maybe we can turn the AC on, for instance. This is just to give a very example. Turn the AC on. And this is just a very, very simplified way of using the program task, right? So the temperature changes. We ask, is it above 23? No, nothing happens. If it's above 23, yes, then turn the AC on. And you can then go to, add else, then maybe, turn just the fan speed up, for instance, when you're reaching a specific temperature. Like I said, you can play around here endlessly, adding ifs on ifs on ifs, or keep it simple and just add specific temperature, turn the AC on. This can be very, very easily done using the program task. Here you can see that we have all my logic is currently saved to the commands, but here we can also have abort commands. So abort commands are basically can be recreated. You can create the same logic here in the abort commands, but instead of running this program task, we need to run abort command. So if I go here to functions, you can see that I can run either run or I can abort the command. So this is run command is every logic in the command. And then abort is all the logic in this section. So we can then recreate the logic here and just maybe do the opposite, for instance. So turn the heater here and then turn it off there. Just use cases maybe they can be used in your building. Okay, so the next task we're going to take a look at is going to be our RGB Mixer. So RGB Mixer, as you can probably tell, is mostly used for controlling RGB devices, RGB lights. And the way it works, you just simply need to link the correct color channel to BOS. So here we have red value. We need to link our correct red channel. So this could be, hue lamps, any Z-Wave, KNX, any RGB devices basically can be linked. And if the device has its own white channel, you can also link the white channel here as well. Link it to white. And now all the channels are linked. In most cases, you have two options. Either device is scaling the RGB values from 0 to 100%. Then you need to enable this scaling. Or if the device is sending the value from 0 to 255, then you need to disable this scaling. This is just a way because it varies between devices, and in some cases, if you have the scaling set to wrong, then the color might not even work or something's going to be wrong. So check what is scaling on the device, and then set this function correctly. And you can either play around with the color picker here, change the coloring, use any presets, or if I go to my client, we can also use this color picker in the client as well. So this is the way it looks in the client. They can either use this color option here, set a specific value, and you can see also how the colors are changing as well. So they can either use, let's say, this value, or they can use the preset colors that are here below. So yellow, and you can see now the green and red are all in, and then the rest are off. And they can also, of course, play with the white channel here as well. We have a separate white channel. If for some reason you start using the RGB mixer and you don't see this white channel needs to be enabled manually, because by default, not all of the devices have this white channel enabled. So all you need to do is you need to select your RGB in the visualization and enable white channel here. right? And if I disable the white channel now, you can see that if I open up the client, the white channel here is not visible anymore. So if I want to control the white RGBs on the device, then I need to enable the RGB mixer. Sorry, I need to enable the white channel. That's basically how it works. And you can of course use variety of our other tasks to play around with the colors. You can create specific scenes that are gonna reflect the colors and so on. The next task we're going to take a look at is going to be our scalar. So the scalar was it's basically the latest task that we added in BOS. It was added in the recent update. It was highly requested just because in most cases you have a specific data and you just want to upscale it and display a different value. And how the way scalar works, you just simply select an input value, select input, and of course select the output. And like we did, if you remember with the analog log and the counter log, the same scaling applies here. So the K is going to be multiplying the value, and then the N is going to be adding the value. So if I go now we have times 5 plus 5. So if I go to my client, select the scalar, and if I add the input value 5, BOS is then gonna throw out 30. So it's going to be 5 plus 5 is 25, plus 5 is 30. And this is the way the scalar works. You can scale and output data quite easily. You can also use here the minus basically, so you can descale or reduce the value as well. So if I go input value 5, see now instead of 30 we have 20. So we have 5 times 5 is 25, minus 5 is 5. So depending on the output value that you want, you can then tweak this data around and display the correct value that you need. Quite simple, straightforward scalar task. The next task that we have is going to be our scene. So scenes are highly used in basically all of our projects. Scene, of course, what scene does is basically controlling multiple devices at once, right? We can add a trigger in. So like we did before, anything in the configuration can be a trigger. So movement detection, alarms, in most cases, if you have alarm turns on, you can run a scene, turn all the lights on, for instance, or brightness outside turns the scene. Anything can be used as a trigger. And of course, the clients can also manually run a scene in the client. When we get to that, I'll also show you how that is done. And the way the scene is created, very simple, just simply select the device and drag it in. So like 1, 2, 3, 4, and 5, right? And then depending on the scene, these devices are then going to be turning on and off, right? Let's say this scene is going to be our lights on. This means that currently all the lights are turning off, and I need to set this to true. Set the value to true. Now this scene, when this scene is going to be triggered, all these devices are going to turn on. And of course, you're not limited to a specific type of device, right? You can turn here. You can add your KNX, Z-Wave, Modbus, BACnet, all the devices that are supported by BOS can be added to a scene and then being controlled. If I go to my client and open up the scene tab, here you can see all the lights now in. And if I run the scene, all the lights are turning on. I should maybe create an opposite scene, but let's just leave it as is for now. And every time the scene is going to be run, all these devices are going to turn on. For the scenes, we also allow a specific freedom to the clients as well, because the client can also tweak which lights are going to turn on using the client. So they can click this wheel button, and they can choose which device are going to turn on and which device are not, because in most cases you create the scene as a system integrator. Maybe you create a scene for the client, and then 2 months later the client says, oh yeah, the scene is turning on too many devices. They can tweak the scene as and make it their own. Basically, they can choose which devices are going to turn on and which devices are not going to turn on. One thing that I also wanted to explain, did I miss anything for the scene? I think I had something else planned to show. Okay. I think I had, I think I had. Oh yeah, delay. Yes. Sorry. I had. I know I had another thing that I wanted to add here at the end for the scene. If you have, let's say, hundreds or 200, 300, a lot of devices in the scene. It's not smart to control all of these devices at once, right? If you have, let's say, 500 KNX lights, it's not too smart to turn them all one at once. You're going to be overwhelming the KNX bus in this case. So that's why we created this delay here. So delay is in milliseconds, and you can increase this value, and then BOS is going to slowly turn these lights on, and you're not going to be overwhelming the bus in this case. So let's say we're going to turn all these on, and when now we added the delay, you will see now the BOS is going to slowly turn all of these devices on. So this is a smart idea to do, especially if you have hundreds of devices, and it's not a good idea to control them all at once, right? So this is why we have this delay option here in the scene. Similar to scene, we also have a schedule task. So schedule task does fairly similar things that scene does. Schedule will just allow you to add specific time events, right? You can schedule when something is going to happen, hence the name schedule. And the way everything is done, here under the commands, we're going to tell schedule what to do, right? So we have options. We can either run a function, so maybe we can run a scene, so run lights off scene. We can add a fixed value. Fixed value just means that we are going to be constantly sending the same value, and it's not changeable, right? When we set schedule, let's say value 1, and let's say 25, every time the schedule is going to run, it's always going to send the value 25. This cannot be changed because it's a fixed value. But if you want to change this value, and if you want to change it in the client, we can also use this custom value option. So custom value, or let me just rename it so we know what's going on. So this is a fixed value. You can of course change the display name, so it's more clear in the client what you are doing. And let's add custom value, and this is going to be our custom value. So now we told the schedule what to do, but now we're going to tell the schedule when to do these things. So this is where the time events come in. So we can add a time event, and you can see now this is the option for our time event. So let's say we want to first control the scene. So we can this is the task that we are controlling. So let's say scene for the lights off, and we can use of course time. So time of day, at 11:05. This was before. Let's say at 9 o'clock, for instance, all the lights are going to turn off. And we can also here change the repeat pattern. So when this is going to happen. So either each day, every specific day, or once, just add a date, and only then this is going to happen. And you can then repeat this monthly or every other day. If you want to link this to a variable, instead of having it led by time, you can also use the sun position, right? So you can use dawn, and you can see now the time has changed. And of course, depending on your current, location or the way the sun is, this time is then going to constantly change, right? Because every day the dawn is a little bit different than the rest day, right? Days are shorter, days are longer, and so on. And you can choose dawn, day, dusk, or night, and you can see these values then changing, right? And it's constantly going to be correct, right? Not, it's not as dark at 9 o'clock now that is going to be, in the winter time. So if you want, you can also use the sun position, or the weather status as a event type. So now we have the lights. We can add another event. Let's say a custom value of, let's say 25, and let's say maybe we want to do this, I don't know, let's say just during the week. And we can also add in the fixed value. So now we have as you can see, now we have all the three functions that are here added, and they can be run in the client. And if we go to my client and go to schedule, you can see the schedule is here at the bottom, and the client can enable or disable the schedule. So if for any reason they don't want the schedule to work anymore, they can disable it. And they can also click this wheel button, and they can play around with the time settings, right? They can change they can change the functions, so they can switch between different functions. They can change the time, so instead of, let's say, 2048, they can go to 2021:48. They can change the specific date, or just once, so all depending on what they want. And since this one is a custom value, they can also change, what the schedule is sending. But they, as you can see, they cannot change the fixed value, just because we said that there's going to be fixed and it's not changeable. And they can, of course, if they want, they can also add their own schedules. They can create a new schedule, completely new time, completely new event. They can play around with the schedule, as much as they want, and make it their own, basically. Okay, so we only have 2 more tasks left, so we are more or less right on schedule for today. Hope that you're all still here. I haven't checked the. There are some questions coming in. Good, I have Matisse here answering them in the chat. So you're quite active. Excellent. See, still a lot of people here. I'm glad that you made it this far. Hope that you learn a couple of new things, and hope it's not too complicated or too boring for someone. Okay, so let's continue. The last 2 tasks that we're going to take a look at is going to be our first off is going to be our thermostat. So thermostat is mostly, of course, used for controlling the temperature of the building. Taking the input values and then to control the heaters, basically. We have different types of thermostats. First off, let's go with switching thermostat. And all we need to do is we need to link the correct input value. So the input value is, in this case, our current temperature, right? This is the temperature of the room. And then depending on the temperature of the room, we're going to be then controlling our heater, basically. So the output, we have 2 options here. First off, the output value. This is the 0 or 1, so true or false. Or we can have the continuous output value. This is going to be from, let's say, 0 to 100, all depending, of course, on the heater that you have. So let's just use the heater to turn it on and off. And here, the heating is going to solely work around the set points that we set and the hysteresis values that we set, right? Currently, we have the hysteresis set to 2, which, if you remember, when we went to the analog threshold, the temperatures are then going to be, the heater is going to be turning on and off, depending on the current temperature and then the set point that we set. Okay, here we have also set point limits. This is just a client limitation because, some heaters or some thermostats are not going to allow you to say the temperature 32 or 5 degrees. Here we can actually limit how far the set point can go. So if I go to my client and go to thermostat, here we can see now, let's say this to heating. Here we have the set point temperature set to 17. So what we need to do is the heater needs to heat up the room until the temperature reaches 17 or more in this case, right? So if I go to 15, heater still on. And even if I reach 17, the heater is still on, or 18, that's because we have the hysteresis set, right? This is the hysteresis value, the kind of the wiggle room that we have for the heater not to turn on, right? And as soon as we reach 19 degrees, the heater turns on, right? It's not, how the temperature is. It's not too smart to, constantly turn on and off heater when it reaches a specific value. It is good to have a hysteresis there, so the value can kind of slowly fluctuate and then slowly turn the heater on and off. This is for the switching thermostat. If you have the PID thermostats, so let's say if you have radiators or underfloor heating, split units and whatnot, this is then the heating is then going to be controlling in the PDM cycles. So if you're familiar how the PDM cycles work, instead of having the hysteresis value sending, let's say, to specific value, then waiting for the temperature to reach the hysteresis and turn on and off, the PDM cycle is then going to be turning on and off the heater with the specific cycle and, of course, the temperature. So if you say you set the temperature to 17 degrees and currently is at, say, 15 degrees, and the heater is running at, let's say, 50%, that means that the PDM cycle is going to turn the heater on for 5 minutes and then switch it off for 5 minutes, because the PDM cycle is set in minutes here. So depending on the set point, depending on the current temperature, And the cycle here, the heater is going to be turning on and off basically in cycles, right? If we have 10-minute cycle and the heater is at 50%, that means that, like I said, the heater is going to be working for 5 minutes and then turning off for 5 minutes. If it's the 70%, it's going to work for 7 minutes and then turn off for 3 minutes. And the user interface may look the same when you go to radiators or floor heating or split units, but the math behind it kind of works differently. Don't want to go too deep today, but yeah, it does matter which type of the system you set here, so you can have the correct, the correct way of heating the building. Okay, so last but not least is our timer task. So what timer does, you can use timer in a variety of different things. You can, turn on a specific device for a certain amount of time. You can add it on the loop. You can control multiple devices here. You can play around with the timer as much as you want. I'm just going to show you, the way the timer works and how you can set it up. Of course, we need to set a start and stop trigger. So when the timer starts and when the timer stops, let's say start trigger, I'm going to go to my start and stop. And since this is a start trigger, I'm going to turn it on. Stop trigger, I'm going to turn the start stop off. And now we have the triggers to when to start and when to stop. And now we're going to tell the timer what to do at a specific time, right? So timer, we can either run a function. So you can again, run a scene, on scene, off scene, or you can maybe turn a light on and off here. So value for true, light turns light on, and then add another one, fixed value for false, and add light off. And now we need to tell this timer when to turn these devices on and off. So on start, we need to turn the light on, and maybe at the end, turn the light off. So what this is going to do, when the timer starts, the light is going to turn on, and when the timer ends, the light is going to turn off. And it's as simple as that. So if you go to timer, hopefully everything works correctly, turn it on. You can see that our seconds are currently set to 10. So the light is going to be turned on for 10 seconds. And when the timer runs off, the light is going to turn on. And you can change the intervals here. You can change the second. You can change the minutes to control the time. You can also add stop command. So you can also manually turn it off. You can turn it off. You can pause it if you want. So you can, if I turn it on and turn it off, the light turns on. So this is just because we have the stop command added in now as well. So you can play around adding the start, stop, pause commands. You can also add a auto restart. That just means that as soon as the timer runs out, the timer is going to reset, and the light is going to turn on again. Okay, this is basically all from my side for now. I think we went through all of to give a quick recap, we went through all of the tasks basically, and I gave you a nice little use case in the client as well, how everything works. Let me just check the teams here, what's going on. There's a lot of questions I see. We are gonna take a short break for now, maybe 5-10 minutes, so I can get my voice back, maybe get a glass of water. Okay, I'm back. As promised, now we're gonna have 4 simple practical examples for you ready. So if you've been paying attention a little bit during the presentation or the training, the exercise should be fairly simple. They're just meant for you to know the tasks a little bit more, and also at the end of the time when the timer reaches out for the tasks, I'll also show you as well how the tasks are done, so shouldn't be too hard. Okay, so the first task, I saw that Flavio was sending you the file where you can get the same configuration that I had today. because some of the tasks are referring to specific values that are in my configuration. But if for any reason you don't have it, you can still try to somehow recreate it, or at least look at how the exercise is done at the end. So the first exercise is going to be the movement detector. So you have the explanation here. The estimate time, 7 minutes, should be more than enough for you to finish this exercise. And I will leave the screen with the example steady like so. And I'll again mute myself. I'll be also in the chat, maybe answering some questions. I'll mute myself, and then I'll be back in maybe 7 minutes, and we can go with the exercise number 2. Okay. Okay. Well, good luck. So the time was up for the first exercise. I hope that you were able to recreate it without any issues. Shouldn't be too hard. This is gonna be the second exercise. This is gonna be the timer, so shouldn't be too hard as well. Again, roughly 7 minutes. I'll leave the timer. You can read through the text. I think Flavio, all should have the configuration already prepared, and you can then shouldn't be too hard to do the second exercise. I'll mute again. If you have questions, I'll be in the chat. And yeah, good luck. Okay, I hope you had that you had enough time to do the exercise number 2, the timer. Let's go with the exercise number 3. Again, fairly simple program task. Shouldn't be too hard. We went through the program task in the presentation as well. So this is the exercise number 3. I will leave it up as before. I'll be also in the chat, so you can continue on with the questions. I'll try to answer them as many as I can. And yeah, again, roughly 7 minutes, and I'll be back, and we can do then the final 4th exercise. Okay, it's time for the last exercise for the day. The last exercise is a little bit different. We just wanted to maybe show you how the importation of examples work. So there's just a short description on how to import a specific example from our website. So as someone posted in the chat that they created their own converter, I do encourage you to post the example on the website. As mentioned, if people find it interesting, people can use it. We also try to reward people that are posting examples, so please post the examples there. And as Flavio is also replying to your questions, if you have any specific, more technical questions, maybe that may not be referring to today's training, again, open the ticket system, or maybe contact us by email, and we can then arrange maybe some remote session, and maybe take a look at the issues together and try to resolve them. Again, last exercise, I'll leave the timer running, keep the text up, and then after this, I'll be back, and we can then go through the exercises, and I can show you how they're done. Okay, so that was all the time for the last exercise. There were some questions that were shown in the chat, so hopefully we answered many of them, all of them. Of course, there are different levels of how should I say, BOS knowledge when it comes to these trainings. Of course, it is, we do try to give it an overview how the tasks and devices work. And of course, if we have something a little bit more specific, let's say CBus in this case, it does take quite some time for you to get acquainted with everything and how everything works. So like as mentioned in the chat, we can of course try and arrange something, a remote support session, and maybe we can figure out this integration, help you out, so we can communicate with your devices. Also, the first exercise that I'm going to be recreating here, I'll try to do it, simply and fast. Probably not, hopefully not going to take too much time. The first exercise was the movement detector. So we went to the movement detector earlier. For now, I'm just going to recreate another movement detection here so I can show you. And the exercise tells us use the Z-Wave Hall movement sensor to turn on a KNX Hall light. So all of these names should be in the devices. So here you have our KNX and Z-Wave, and we need to use the Z-Wave. Where was it? Hall movement sensor. So we need to use this movement detection here. See if I can drag it in. Yeah. So drag in the movement sensor. This is a Z-Wave device. This is a Z-Wave device for detecting movement. And of course, the output value then needs to be linked to our KNX. I think it's under lights and Hall. And basically, that's it. The exercise requires. It does require you to create a visualization, but I'm not gonna drag and drop the 2 buttons in. You can, of course, if you need. But this is basically the gist of the first exercise. You need to add a Z-Wave motion detector and add the KNX output light to turn the device on. If you cannot, of course, if you have issues currently, I don't know, there are a couple of people talking about you cannot log in the website. We did a couple of tests during this time. We couldn't recreate the issue. But if you have issues connecting, and since if you cannot connect to the website, you cannot open a ticket, you can email us. Maybe Flavio will send you our support email. It's at support.comfortclick.com. Flavio, if you can just type in the chat support mail, you can email us and we can maybe see what's going on with your connectivity to the website. So that was the exercise number 1. The exercise number 2 was the timer, where we need to BOS training configurator prepare the timer for the Z-Wave wardrobe light. The timer settings turn the light off after 10 minutes. And we can also then create a visualization for a panel. So again, create a timer task. And then we need to just add basically the timer command basically. So fixed value, we can go to Z-Wave. What was it? Wardrobe light on and off. So true needs to turn light on. Turn fixed value. Turn the light false and turn light. You can, of course, then, these are set. Now we need to tell what's going to happen. So start command, turn the light on, and on end command, turn the light off. Since the example does say to set the timer for 10 minutes, and the way you can set the specific time, you can always select the timer, go to values tab here, and here you have all the functions. So here is where you can set the 10 minutes first. So set the timer for 10 minutes. And now, when the timer is going to start, the light is going to turn on for 10 minutes. This will be the exercise number 2. The exercise number 3 is going to be the program task. So program task, run all scenes, run first thing, run all off scene for KNX scenes when the paradox alarm is activated, and when all on scene when the alarm is triggered. So we need to create a program task and then ask for the status of the alarm. So paradox alarm is in, and all we need to do is to add a program task. Under triggers, we need to then check the status of the alarm. So the partition of the alarm, and we need to set the status. So here on the status, here you can see we have armed in alarm, right? And instead of asking this, I'm just gonna do it every time it changes. So every time the status of the alarm is gonna change, run this program task. And then ask if the partition is armed, right? Let me just double check. When the alarm is activated, run all off scene. So when it's armed, so the alarm is activated, run I think we have a KNX scenes all on basically. So this is what the first part of the example requests. One thing you can do here, I can actually copy this if sentence, copy it, select the main start, and paste it in. And now all I need to do is I need to change, instead of armed, I need to go in alarm, which means that the paradox alarm is in alarm. And then instead of running all, we did the opposite. Sorry. Now I need to run all off scene, and now I need to run all on scene basically. So the program task is going to start every time the status changes, and it's going to ask if it's in armed, then turn all the lights off. And then it's going to ask if the partition is in alarm, then all on scene is going to be triggered. Fairly simple, shouldn't be too hard to figure out this task number 3. And then the last task was to download the example from our website. So I will go to our page, let's say ComfortClick.com. If you don't know already, all the examples are under support. And then if you go to examples, right, here is where, people, all of our clients can post the examples, the one that was mentioned earlier with the converter. You can post it on our website. We will review it. If it's okay, we will then publish it, and you can get a reward if it's if it's a good task and can be used for anyone. And as you can see, there is a variety of different tasks, from devices to tasks to visualizations, GUI templates, projects even. So there is a ton of examples ready to be downloaded. And this example requires you to download the human-centric light. So human-centric light is basically controlling the LED temperature depending on the sun position. So you kind of have this cool and warm lights during the day, depending, of course, on your sun position. And all you need to do is, there's also, of course, a short description how the example works. And what you need to do is you need to download it. As you can see, it's been downloaded to my downloads folder. You go to the configurator to import examples or import a specific parts of the visualization. You will then use this import configuration function. So select this. And as you can see, I tried a couple of times. I have a couple of those here and open it up. Basically, find your human-centric light configuration and or example and import it in. And the next thing to do is simply select add, and we can add it under our tasks here. Tasks, add it in, and now you can see that the human-centric light has been imported to my configuration. And now all I need to do is I need to set this output to the correct, let's say, colored LED. So this is the light that we're going to be controlling. The sun position is already linked, so all the logic and all the complex things has already been done. So you don't need to worry about doing anything. All you need to do is need to link the correct output to the correct device. So I think it's lights temperature. Here is the LED light temperature. Link it to the correct LED of your KNX. This is just an example, and then the light temperature is going to change according to the sun position. And that was basically the last exercise. The whole idea or the goal for the next exercises is more or less just to show you how the importation of the examples work. I saw that there was a ton of questions for during the presentation already, and most, I think all of them were already answered. But if you have any other questions, or if you need to know a little bit more how the task that I already show work, you can feel free now to use the chat like we did before, and I'll try to answer as many as I can. If the questions are maybe not going to be as related to the task, or maybe you have just a general question that might be completely different, you can, as mentioned before, you can always email us, open a support ticket. We'll be more than happy to help you out with your issues or your task, or if you have any questions. I would say almost all of our support during the support tickets is for free. So except if you have some some third-party integration and some complex tasks that we will have to spend a little bit more time reading to the manual, discussing, testing, maybe ordering some equipment. In that case, the support is billable. But for most cases, I would say 99% of the time, the support is for free. Visualization for tunable white. Yeah. With all of these suggestions, thank you for the suggestion. Of course, we will write it down to the suggestion form, see how complicated it is, and then try to implement it into BOS as fast as possible. We do get a ton of suggestions on our forum, on our emails, and everything. So we'll see how this goes. Maybe we can contact you after and see if maybe a workaround that can already be done for this task. For the rest, if you don't have any questions for today, I would like to thank you all for taking your time, taking these 2 hours or so to listening to the presentation. I hope that you'll learn a couple new things. I hope this is going to help you kickstart your journey with BOS. I think we went through all of the tasks. And like I mentioned in the beginning, if you missed it, if you want to know more about how the general is, so this part of the configuration where you have the users, translations, files, templates, and Alexa integration. And if you want to know more about how the visualization itself works, and if you want to know about how all these devices that are supported by BOS, how to integrate them into your project, feel free to watch our previous advanced trainings where the previous training I went through basically all of these devices. I think we also had we had the camera as well, where I actually physically plugged in these devices and show you how the devices are implemented and how they can work in BOS. Thank you so much for your time, for your presentation. Thank you very much for your feedback. I really appreciate it. We have a better overview for DB usage. Yeah, you can export your logs as a .db file. For now, the exportation needs to be done manually, so you need to manually click this backup button and export this .db file. But in the future, we will also have this automated. So there's going to be a function that can be run, each month, each week, each day. That will automatically export the values to your folder, and then you can then save them later on. I'll stick around, I don't know, depending on how many questions you still have. I already found a workaround with color picker. Yeah, excellent. Yeah, a lot of things, even though currently we might not have a native task or a native device or driver for a specific device, BOS will allow you to create workarounds, integrate devices. You can try to use other tasks to maybe do something that RGB Mixer might not do directly. Also, export to Excel would be super useful. Indeed, yeah, Jürgen. Yeah, we had this discussion, I think, in the past. It is something that is planned. It has been requested. It might not be as easy to do it in the current BOS version. So a lot of the things that we have promised and are working on are going to be in the next version, where there's going to be a lot more flexibility and a lot more open especially for new suggestions and whatnot. It has been in the works for quite some time, but we're still working hard on it. Still have a ton of people dedicated to exclusively working on the new version, and we have the other group exclusively working on the current version. The train that we had today was recorded, and it's going to be maybe cut, so it's not going to be 2 hour video with a lot of silence during the exercises. So we're going to be cutting it down, and then we will posting it to the YouTube channel. So I mean, you'll probably also get the notification explaining you that the video is up. You can check it there. Should be in full length. You can then watch it in great detail, and also for the rest that maybe skip this. Yeah, I think Flavio and the rest, you're gonna receive maybe a thank you for joining, maybe some link to the tutorial. Regarding the downloading or downgrading the configurator rather, if you are currently, let's say I'm currently in the beta version of my server, so it's even the configurator is in beta. If I maybe connect to a server that is running an older version, you will get a prompt message explaining you, I don't know which one can I connect to, maybe this one. Yeah, okay, there was for support from before. You'll get a prompt up message saying, as you can see here, your current configurator is a newer version and the server is the older version. You can just click download configurator, and then the configurator is going to be the same version of the configurator is going to be downloaded, and then you'll be able to connect to the server. And the same goes if you want to update the server, you can also, instead of downgrade it, you can update the server. We'll try to answer your Germans. We'll try to answer your question. I'm not 100% sure what you think there. Maybe my colleague here can help you in the chat now. If not, we can then maybe schedule this question. We can answer it later. We are there was another question for SIP client. Yeah, it was in the past, but yeah, we are in the future release to implement it. Maybe we can next version, yeah, try to add it in again. So or maybe native 2N integration like we have work around currently with Doorbird. Maybe we can do something about that. Yeah, because 2N. Yeah, the current issue is that the sound we cannot provide with the sound that's coming from the door phone. That's why. Yeah, that's why also more or less each door phone comes with its own app, which you can then use. But yeah, it would be great to have it all in one app. But for now, we suggest you to open the open the app basically. Yeah, like I said, the training is going to be uploaded to the YouTube channel. So, and I think you'll also receive an email notification. Regarding this, and create an average feedback from 4 values. Yeah, maybe we can take a look at this after now. Maybe after everyone leaves, maybe we can schedule something to represent the feedback and control button. We'll figure out something now, and maybe we can answer you for this question. I am slowly running out of voice, so yeah, Matit did send a photo. I'm not sure if this is what you mean regarding if this is a KNX device, because he's trying to do some calculations there. Average feedback, yeah. Yeah, you should receive a screenshot now. Matit will try and recreate this somehow for you, so it's gonna be a little bit more clear. We are creating a simple example for you that should probably work when it comes to calculating the averages. Okay, that is going to work, calculating your averages. And Matita is going to send something here in the chat you can try and import. When it comes to the you could create a task that is going to play around with the RGB mixer. You can combine a couple of things. Maybe you can combine the timer, then when the timer runs out, you can maybe change the values here and use the program task, tweak the RGB. I don't think you're going to be able to send a random value each time. But you could create a loop and then send a specific value, and then maybe you can recreate this, I don't know, 10 times, and then every minute a different color is going to display. That's probably going to thing you can do. That currently we don't have a randomizer that will just spit out a random number for you. Maybe this is also something that we can do in the future, where maybe a randomizer task where every time you run it, different value is going to be spitting out. That's another thing we could add. And then maybe you can implement this in and controlling the specific color of your RGB. But for now, I guess you could create a timer that at the end of the timer, you would run a program task, and then this program task could maybe change the color. Or you can use, yeah, maybe you can use, yeah, a random value could also be maybe time. There is a workaround that you could create. Yeah, you could use maybe the temperature, and that would be a specific value that you can choose. If it's temperature 23, 24, that's different. There's the different values that could be sent. Yeah. Or you can use, yeah, Matit has an excellent suggestion. Or maybe if since there is no built-in randomizer, you could use maybe an online randomant randomizer basically, and if they have an API, you can try and integrate this, and it's going to be constantly sending you different values. Might be a lot of work, a little bit of work for for parties, but you can play around with it and see if you can get it to work somehow. So the way the presence simulator works, you simply add in the input values. So with these are the devices that you want to the device that you want to control, and then basically you're done at that point. You can also add some other conditions if needed, but as soon as the devices are in the presence simulator, and of course you set them to true, that means that they're going to be turning on. When you run the presence simulator, start it, you can see that the devices are then going to turn on randomly. You can tweak the intervals, you can change the device count. If you're going to be creating this from scratch, I think that you will have to let's just create another panel, add a frame. Let's just see movement detector. Now we have presence simulator. If you drag and drop the presence simulator in your visualization, you can then see different functions that are for the presence simulator. So start, stop, running, intervals. You can recreate this by simply dragging and dropping different parts of the presence simulator here. Start, for instance, and this will start the presence simulator, and you can recreate this very quickly and create something that looks like this. This is just pre-added in, so you can use this in your visualization, or you can tweak it and add it. I don't think we have a dedicated. Maybe we actually do. Presence simulator frame. I think we actually have it. Yeah. Okay. Yeah. We have a frame, basically a dedicated frame. This is you cannot change this, right? This is pre-created. This is built in the task. So this is as is. But if you want to tweak it, maybe if you want to add some other functions, you can drag and drop different parts of the simulator and maybe create it a little bit differently. Yeah, the current present simulator basically just checking which the current light is and then turning a different light on. The problem is with the RGB, we were required, to send a specific value, and you could use a program task to, let's see what we can do. Program task and then set the value of our RGB. Just a second. Regarding your question for the blinds and for the averaging the average value, if you could just email us, and we will send you the example so you can import it in, and it should be working for you. Maybe, or Matisse will send you a link which you can download. For the RGB mixer here, you can see. You can either send a constant value, which is this, or you can use a variable here. You can use time, or maybe I don't know time. No, time's not going to work. The problem is now, or you can calculate it somehow and then use here time hour. This should, I think, should return a value to the RGB mixer. Once it's run. So this is probably going to generate a random thing that's going to work for the RGB. You can give it a go. You can try it. It could work. And with these will now post the example. So this is the example that Matitz made quickly now for the shade control. Here we have some shade controls, and then here we have the feedbacks, and then all of these feedbacks are then added to the min-max or the average value here. The program task is then, I'm guessing, converted into integer. No calculation. And then this is then converting the double to integer value, which you can then use this integer here to display it, the average value. And this, okay, yeah, I see. We just made this on fly, so that's the first time I'm looking at it. So double to integer, every time it changes, so then it writes it to average feedback. Yeah, so it does this does the calculation, then this converts it to integer, and then the program task writes it to the feedback. So the average feedback is used the shade controller. Yes, and then the average feedback has 110, and this is here set to status. So you can then see the one button, and shades control will then have, you can use this one button. This one will be for control, and you will get feedback for the average shades. Hopefully this answers your question regarding the average control. Yeah, okay, so if there are no additional questions, I would like to thank you again for taking your time today to listen to today's presentation. If you will, remember a question later, as mentioned before, you can contact us, open a ticket, and we'll be more than happy to help you out. Thank you again for taking your time, and have a great rest of your day.